Let's begin. Good evening, everyone. Welcome to McCarthy Observatory's November 2nd Saturday Stars. My name is Roger Moore. We're coming to you tonight a little different than we've done in the past. We're coming over Facebook and YouTube rather than just the Zoom platform. For those of you on YouTube, if you could subscribe to our channel, that would help us in the future, make this a little simpler. So tonight we have four great presentations for you. The first will be Dr. Parker Moreland, who will tell us about what's in the sky this month, or the sky tonight. Following him will be Bob Lambert, who will give us an overview of the McCarthy Observatory's Meteor tracking technology. After Bob will be Bill Cloutier, telling us about Sentinel-6, NASA's Sentinel-6 satellite, and monitoring Earth's oceans. And then we'll close it out with Mark Polanski and a discussion on Crew 1 and manned spaceflight returns to the US. So in between each one of these, we'll try and let you ask some questions. You'll have to do that through the chat box on whatever form you're using. But hopefully we'll be able to see that and answer those questions in between each presentation. With that, I will turn this over to Dr. Moreland.
Okay, trying to share my screen here, not working. Maybe it is working. Why am I not seeing myself?
We can see your screen, Parker.
Could you see my screen? Why can't I see my screen? Well, anyway, maybe it'll work when I bring up Stellarium. I understand it's quite clear out tonight. And so maybe you'll be able to go out afterwards and take a look at the stars. I'm going to do what I have done for years before going out to observe. I'm going to preview the sky with a computer planetarium software, simulates the night sky. One we're using is the same one that Roger's been using the last couple of months. It's Stellarium. And I'm not going to use it quite the same way that Roger did. I'm going to use it. He did beautiful slides with screenshots of Stellarium annotated beautifully. I'm going to use Stellarium raw and live just the way I did before going out to view. So here's Stellarium, where I always started in the western sky so that you can catch things before they set. And you'll notice that tonight, Jupiter and Saturn are about to set in the western sky. I've got a date and time in the upper right-hand corner for you to look at. And they're about to set. There's an interesting thing about Jupiter, I should tell you, or the pair actually, Jupiter and Saturn. They are in conjunction, they're very close to each other, but on the winter solstice, December 21, they're going to be very close to each other, 1/10 of a degree apart, which is 1/5 the diameter of a full moon. So if you want to see a really good conjunction of Jupiter and Saturn, go out on the solstice, December 21, and take a look. You probably have to go out earlier than this because they'll be setting, pretty soon. But check that really close conjunction next month of Jupiter and Saturn. You'll notice there's a red line on here. It's not in nature. It's called the ecliptic. And you'll remember that the 8 planets revolve around the sun counterclockwise when viewed from the north in nearly circular orbits. And it turns out all 8 of the orbits are in about the same plane. And astronomers call that plane the plane of the ecliptic. And you'll notice, sure enough, the two planets that we see here are on the ecliptic, or very close to it. And in a minute, we're going to see that Mars is also. And if you think about it a little bit, the sun is in the plane of the ecliptic. And sure enough, this is the path the sun takes through the sky every day. Now, in addition to the two planets, we have several stars, the brightest being Vega, which is part of the constellation Lyra, the lyre. And then we have Altair, part of Aquila, the eagle. That's this constellation down here. And then the next brightest star in the group is Deneb, which is the tail of Cygnus the swan. These are the wings, this is the head. And if you're having trouble making these out, in Stellarium, you can turn on these stick figures that help you notice there are the wings of the swan. Here's the eagle. And if you have even more trouble, we can actually put the names on for you if you like. So this is what Stellarium does for you. It actually can label the bright stars. Now I'm only going to pay attention to naked eye objects tonight. No telescopic things. So that's the western sky. Got two nice planets in view. We'll go around to the southern sky. And as I promised, there on the ecliptic is Mars, or very close to it. And our other stars are still over here. Now, Mars is in the midst of doing something very interesting right now. In fact, tomorrow night will be a particular turning point for Mars. It's in what we call retrograde motion. And this is an optical illusion. Mars does not do this in actuality, but it appears to us from on Earth that it's doing a do-si-do in the sky, but once each turn around the sun. Now, up to 400 years ago, this was very surprising and very nearly unexplainable to astronomers of that time. Once we understood that we have a heliocentric solar system, one centered on the sun, then this becomes more understandable. So we're going to make a little view and look at the retrograde motion of Mars. Turns out it's pretty easy to do in Stellarium. I'm going to back off time a week at a time. Okay, notice we're on November 14th. And if I go back, there's the 7th. Notice that Mars is in the constellation Pisces. And it's going back, and I'm going to go back to about 4th of July. Oh, I've got to get rid of the ground. Turns out in a computer, you can get rid of the ground and look, and oh, there's Mars. Sure enough, there's Mars, looking at it with X-ray vision through the Earth. And let's go on back down to July 4th. And there is Mars. It's still near the ecliptic. So now we're going to do some things. We're going to select Mars, and then I'm going to turn on what's called tracking in Stellarium. And then we're going to go forward, again, the same week at a time, back into next year. Now notice that when we start off, Mars is going to the east. You would expect if the planets are revolving counterclockwise around the sun, when we see them against the background of fixed stars, they should appear to be going east. And that is in fact what's happening. Uh-oh, what's happening? This is called retrograde motion. Apparently, when viewed from the Earth, Mars appears to be going westward. We're back to today, okay? Now, I told you something interesting happens tomorrow. There it is, turns it back around. Right in the middle here, right in here somewhere, was what's called opposition. That's when Mars is directly opposite the sun from the Earth. So this apparent effect occurs near opposition of a of an outer planet. And this is the part that's called retrograde motion, where everyone got confused several hundred years ago. Why would it do that? The planet is not doing this because we are passing Mars. We are going faster in our closer to the sun orbit than Mars is. And as we come up close to it, the angle of observation of the stars behind Mars is changing with respect to Mars. And it appears to us that Mars is going the other way. It's not really. It's not doing this. This is only apparent from Earth, but Stellarium is showing us the picture of what Mars would look like from Earth. So now we can get back in business. We'll turn all this off. And do this. And there we are. So this is again the southern sky. Let me turn the ground back on again so we actually have a horizon. There we are, the south. I'll get rid of that. And now we're going over here. Okay, I didn't get back to where I wanted to. I have to go back to today. There we are. Still in Pisces. And moving on over to the western sky, we see that there's this bright star is Aldebaran in Taurus. Up here, the Pleiades, very beautiful open cluster. You can see that naked eye. It's more of a blob, but you can see it with your naked eye. And then a bright star Capella over here in Auriga. Now, let me show you something that your kids might see. I doubt if you'll see it. I certainly can't see it. But up here in this area, I've got to blow things up a little bit. This is the one telescopic view I have to give. This is the galaxy Andromeda. And young people in clear skies like tonight can actually see it. It's just a cotton ball, a very dim little thing, but young people usually can see the galaxy. The only galaxy visible with a naked eye. And it's in Andromeda, obviously. Now let's go quickly to the northern sky. I want to show you one little thing. Right now, the Big Dipper, which is this asterism in Ursa Major, is the name of this constellation. But the Big Dipper, as Roger Moore has taught you, if you take these outer two stars of the bowl and just go up from there into this dark area of sky, the first thing you'll come to is Polaris, okay, the North Star. And it's right above the spin axis of the Earth. The other bright stars, by the way, and these are mostly magnitude 2 stars, are Cassiopeia and, of course, the Big Dipper itself. And some of the stars in Cepheus are pretty bright. But one thing you can do in Stellarium is speed up time. You saw me reverse time by a week at a time. You can just speed it up like that. You slow it down a little bit. And what you're seeing there, you see that the clock is running up here. We're going through the night and the Earth is spinning on its axis. It will come around to dawn. And even though I've turned off the atmosphere so we don't have any light pollution, sunlight is now at dawn shining on the surface of the Earth, and we're seeing that in the simulation here. But this is, you'll notice the one thing that's not spinning is Polaris, because it's right above the spin axis of the Earth. Well, that's a brief introduction to, if you have kids, you might enjoy another feature of Stellarium, the artwork that they apply. And this is artists' conceptions of the various constellations. Here's Cygnus the Swan, as promised. Hope you can go out tonight and see some of this. Have a good evening.
All right, thank you, Parker. We're running into a technical issue with our Zoom account. I think we're going to have to sign off for a minute and then sign back in again.
That 10-minute sign meant something?
Yeah, and I'm not sure why that happened. It should not have happened.
Well, if it's not a paid account, that's what.
No, it is though. It's
Oh, well,
our
then.
paid account.
Oh,
Supposed to be the paid account.
how many are viewing, Mark?
We've got a couple. We've got about 10 or 12 on Facebook and about 22 on YouTube.
Wow. There you go, Elaine.
I know.
So what's the
You
best way
were
to do
right.
So while we deal with the Zoom issue, I've had I set my telescope up outside and I've been doing some imaging. I have the Bubble Nebula up right now. I think I can share this way because I'm basically running this broadcast from my desktop PC, and I can use this to hopefully pull up this. If I screen share this, there we go. So now YouTube and Facebook are seeing what was a 10-second exposure of the Bubble Nebula. Pop over to a different filter, and that might make it look a little more interesting.
So can you communicate to the audience while we rekindle Zoom here?
I can't speak without being on Zoom, but I at least have this up so that we're broadcasting something out.
All right, so we should all log off and log back on.
Yep.
correct? I'll have to create, I think I'll have to create a new session and send the information to you.
That's gonna take a long time.
No, it's a couple minutes.
All right, I'm leaving.
All right.
Okay.
Roger will email the link to us and we will rejoin in a little bit. We'll be right back. Go.
Good evening. Thank you for staying with us. We've had some technical difficulties, but we'll work through them. So we've rearranged some of the presentations. I'm going to go next and talk a little bit about a mission that is coming up in about a week from today. And it's called Sentinel 6, Michael Freelick. Michael Freelick is a former director of NASA's Earth Science Division, and this particular satellite was recently named after him. But Sentinel 6 primary mission is to monitor the world's oceans. It's an international mission. NASA providing some instruments, is providing the rocket. It's a collaborative mission with the European Space Agency and a number of other organizations in Europe and in the US. Tentatively, if weather holds, the launch is scheduled for next Saturday morning, and it's being launched on a Falcon 9, a SpaceX rocket from the Vandenberg Air Force Base, which is on the coast of California. And the spacecraft will be placed into a polar orbit, nominally about 830 miles above the surface of the Earth. And that will allow it to revisit the same spot on Earth every 10 days or so. The basic objectives monitor the sea level, which is a continuing process. We'll get into that in a second. This also can provide information on the atmosphere, particularly the layers right above the ocean, temperature, humidity, which will be used to enhance our forecast, particularly, for example, hurricanes. It's very important to know the ocean temperature as far as how much energy is being transferred into the storms. It's going to help researchers understand how the Earth's climate is changing and provide some additional information how the coastline is changing and how fast it's changing due to the rising sea levels. Now, Sentinel 6 is a continuation of satellites that have been launched since 1992. And these have been in service overlapping. I'll show you a graphic in a second. But Sentinel 6 is actually two spacecrafts. There's a Sentinel 6A, which is launching next week, and a Sentinel 6B, which will be launching in about 5 years. They're identical spacecraft. They're being launched so that we have a continuing presence and the ability to continually monitor ocean levels over a long period of time. So just a graphic may be a little difficult to see, but you can see the progression of satellites and their overlap as far as the time periods when they're monitoring the oceans. So right now, this is the satellite. It's been placed into a fairing, which will protect it as it goes through the atmosphere. Of course, once the rocket is outside the bulk of the atmosphere, that fairing separates and falls off to be recovered and exposes the satellite to space. And then the satellite will detach from the second stage and make its way into its orbit. Just for scale, that satellite's about 17.5 feet or so high. See, it's all folded up. So if everything goes well, the weather cooperates, this is what it will look like next Saturday. It's an early morning launch from Vandenberg, about 9:30, I believe, in California. And you would see the rocket launch from a nice location right off the coast there. I was out there 2 years ago and it was completely fogged in. So I heard a launch, I felt the launch, but I didn't see anything. So that's what happens, I guess. So this is a satellite in orbit that solar panels will deploy and power the spacecraft. Now, why are we looking at the ocean? The oceans control the Earth's weather. I mean, the oceans affect the heating, the cooling, the humidity. It affects wind speeds, directions. The oceans really are the Earth's regulator. Of course, they also cover more than 70% of the planet. So as the Earth heats up, the oceans have been absorbing this heat. About 90% of the excess heat produced as the Earth warms has been absorbed by the ocean. But eventually that ocean will re-radiate that heat back into the atmosphere or raise the temperature of the ocean such that it will melt ice shells, and what we're seeing in Antarctica. So it's very important to know what's going on in this large body of water that covers more than half the Earth. Now we know that the sea level has been rising. We've been watching it, monitoring it. But since 1993, when we've had satellites in orbit, we're getting a much better picture because we're getting more accuracy and we're getting a global coverage. So you can see that the ocean levels are rising from a number of factors, land glaciers, particularly in Greenland, also in the mountains. If you've ever been hiking out west and your favorite mountain had glaciers on it 20 years ago, you'd notice that those glaciers have been retreating. We've also seen the Antarctic ice sheet calve and retreat. And as the oceans warm, the water expands. So you're getting thermal expansion, which is also driving sea level. So this graph just shows the contributions of thermal expansion and water being added to the ocean from various sources over time. Since 1880, and we've had means of monitoring the ocean back that far, sea level has risen 8 to 9 inches. It varies. The ocean has its own topography, its own areas where there has been less or more change over time. But the important thing is that the rate of change is accelerating, and it's more than doubled in the past 15 years. And as we're seeing the results, that we're seeing more coastal flooding, what they call sunny day flooding. Has nothing to do with storms. It's just that we're getting inundated by higher ocean levels. Now, back before satellites, and we still have these in operation. This is a tidal house in San Francisco Bay. They had tidal gauges, which are big yardsticks with paper charts, and they'd record the change over time of the ocean, and then someone would have to transcribe the readings from paper to other records. But these are still in place, still monitoring, and we're getting good correlation between the old-fashioned tidal house and the satellites. But the satellites do provide more precision and additional data on the actual atmosphere. So since 1880, you can see the graph has been going up, sea level. The reason this is so important is because almost 40% of the US population lives somewhere that's affected by rising sea level, whether it's flooding or erosion or just intensity of storms. You might hear that we're not having any more storms than normal. It's But the storms, if you follow the forecasts, intensify much more quickly and are much more severe than in the past. And that is a sign that there's additional heating going on inside the ocean. And the other thing that's important, at least from my perspective, is that this has become a national security issue. If you look at what the Pentagon, Defense Department, and the armed forces are worried about, climate change is number one. They're very worried that the rising seas are going to displace millions of people, which is going to cause instability across the world. They're worried about changes in coastlines, their places of operation, saltwater intrusion. They're worried about the loss of Arctic ice and the fact that other countries are moving into the region either for resource mining or just to establish a presence. We've seen a lot of that with the Russian contingent. And as I mentioned, they're also worried about the storms being more intense. And this all threatens their bases of operation. So when our Defense Department and military are worried about something, there's something to it. So if you want to stay better informed, there's a lot of data out there. NASA has some very good websites that monitor the climate and all the factors that go into it, including ocean rise. And there's some other good reports out there that you can be up to date on what's happening. So if you want to watch the launch, all you have to do is go to nasa.gov next Saturday. Coverage starts at 11:45 in the morning. Launch is 12:17 Eastern Standard Time. So hopefully, weather permitting, you get to see a nice launch off the coast of California. Okay, thank you.
Mark, you've been handling all the questions, okay?
Yep, we're good so far.
All right, Mr. Lambert, are you ready?
Bob, you're gonna have to unmute. There you are.
Good evening. I'm Bob Lambert, and I'm going to talk to you for a few minutes about one of the key science thrusts that the JJMO team is doing and has been doing. This is called Meteor Tracking Science. And we are using we're now using one camera. We will deploy more, hopefully, as we go forward, to capture the motion of a meteor descending through Earth's atmosphere. So these are shooting stars that you're all used to seeing with long trails, and we're focused on the very brightest ones. And we'll say why. The goal is to capture those rare events when meteors impact Earth, becoming meteorites. So the context of this bit of solar system science is what we call our three-legged stool. And it's been 20 years of progress to build these legs of the stool solidly. One thing we've worked on primarily for 20 years is potentially hazardous object tracking, with over 2,000 submissions to the International Astronomical Union Minor Planet Center. So these are tracking and submitting our observations that are accepted by the Minor Planet Center for asteroids and comets that they think are potentially hazardous to us sometime in the next 100 years or so. And we've had a few actual discoveries in the process, just serendipitously. Second is meteorite science. We have a very diverse collection of 240 meteorite specimens. And we have a professional microscope donated by the Danbury Hospital to examine in amazing detail, and a special HD video camera to explore and teach with, to get down into a very, very microscopic level of these fascinating specimens. And now meteor tracking science, searching for meteors that may impact in our region. So we have a tracking system, a camera on our roof that is focused on capturing bright meteors, fireballs and bolides, we call them. And they're intended to be the prototype for a New England tracking network. Our dream is to start a New England tracking network. There is nothing in all of New England that does this work. Shame on everybody. So it's been developed by the JJMO team over a period of time, and now working to pair with a sister organization to do precise calculation of descents. So the object of interest are fireballs, are objects that are brighter than Venus in the sky. So minus 4.0 magnitude or brighter. The bigger the minus number, the brighter things are. But the ones that are fireballs that detonate and cause very bright flashes and explosions traveling down through the atmosphere are called bolides. So those are the ones we're most interested in. Those are the ones that may impact Earth. So the meteor tracking technology, we have some mighty fine engineers on this team, impressive beyond belief. So the technology has a camera, a controller for the camera, a capture software, a pretty high performing computer, and analytic software for the ones that have been captured. And so here's the camera with its cover off, with the lens and all the controls. And here it is ready to be mounted with these U-bolts that will mount on a pole. Here's the camera with its dome on, weather protection. Here's a controller that controls voltage, and we have to heat the chip and cool the dome. So there's heating and cooling going on through this controller. It captures 30 frames per second, and it captures and logs when it's triggered by motion detection. And it's set up so it just runs for all the dark hours automatically, and it knows when the days get shorter and the days get longer, and it adapts to that. So here's a screenshot off of our recent capture of a captured meteor trail. And this was a very dramatic bolide on November 8th that hundreds and hundreds of people observed over this region. It was going this direction. And here's the star field at that time. We saw Capella and Mars, as Dr. Moreland told us, and then Vega and Altair. And this is north, this is south. So this is going west-southwest at a very high rate of speed. And so this is where it gets into the atmosphere. And this is where it finally extinguishes, and it traveled a fair number of maybe 150 miles, something like that. So we catch many of them right now. There's a lot of meteor activity. So we're getting on clear nights around 25 events, a few Leonids, a few Taurids, and random other trails. And so it looks like pickup sticks here. These are the tracks of one night's, and you can see it's pretty random. Here's a ground map of a night's event also. So this was looking up in the sky. This is looking from the sky down and seeing where the trails were. and we see them in something approaching 150-mile radius. So a 300-mile diameter to the reach of this thing. And one of the fascinating side effects is that we see lightning close to that distance away, maybe 100 miles away, we see lightning. So that's always disturbing, but it's pretty random. So to calculate a path, an accurate path to impact, if one is likely to hit the ground, we have to have more than one site. We can do a plot like we just showed you, but two sites can do well on a trajectory because you have a baseline distance, hopefully more than 20 miles, and those will both get simultaneous. You have the same equipment, they'll get simultaneous information, and that can be then calculated. And we have a calculating engine that will lay out a path. But to be real accurate, we need 3 sites or more. And then we can triangulate. With 3, you can always triangulate, right? And then so you get a more and more accurate trajectory and possible fall zones. So this is the holy grail for us, is to get fall zones and be the first people to get to the fall zone and capture the specimens. We are about science, so the main objective is to get these samples to scientists, and who can figure out what they're made of and they outgas. And there's an awful lot they can gather now with new instruments. And we might be able to buy our next telescope if we find a nice big specimen, because they go for a lot of money. So that is a side objective, though. It's not our main thrust. So our 2021 focus is to get an additional site working well with us. And we're far along in discussion with a potential partner site. We may announce it any day now. And so in 2021, it's going to be some technical challenges to iron out the linkages for sharing and capture data, calculating orbital paths accurately, get the clocks synchronized between the 2 sites, plunge deeper into what the software can do, and demonstrate ability to network and share data in a very consistent fashion, and then gain approval from it. So once we have that done, we think we can gain approval from a 3rd site. We have our eye on a 3rd site. It would make a fine regional triangulation baseline. And so if we could get that far this year and be on the road to getting that 3rd site, we will have had a successful year. And then to publicize the first New England Fireball network. If we do a good job, we think we can capture a much more extensive network through New England, because there's an awful lot of brain power and technology available in New England. So this is a link. You'll see this off of our website. Link to the Best of Fireballs Google Drive site. It will get updated as we make progress over time. So we average capturing about over 2 fireballs per month. So let's just observe a few. If I can figure out how to do this. Here we go. So that's your typical fireball. You can see its path. It starts out nothing, pop, 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 and it extinguishes. I'll jump ahead of the one we saw a week ago, which got the whole East Coast going. I'm just rerunning it. So these are pretty high energy. That one that we showed that from last week was audible across the fair size region. I did this one because it's the longest trail we've had so far. It covers well over 100 miles. That one's off the screen for me. All right, so you get the idea. So the wintertime, the nights are longer, so we're going to get more events than we will in summer nights. And the odds of getting something that's going to land are not zero. I know of a couple in the last few years that have landed within 25 miles of our house, but both of them landed in water, which is not helpful. Okay. Roger, back to you.
Oh, we got one question for you, Bob, from YouTube. Somebody's asking, what is a bolide?
A bolide is just a fire, I shouldn't say just it's a fireball that's actually detonated. And those bright flashes we just saw, when that happens, we change the name from just a fireball to a bolide. They're fairly arbitrary definitions.
Very nice. I think we should come out and get out and come back in again. We're going to end in about 7.5 minutes.
All right. So Roger, if you could end the meeting and then we'll all just redoing it.
I can do that. Rob, there's still a question on YouTube. Somebody had asked what a bolide was, and you explained it's an exploding meteor. And then they came back. So a bolide is an exploding shooting star. That's the question.
I'm not sure they can hear me.
I can't yet.
Yeah. So Mark, why don't you just answer it?
All right, 1 second.
You'll be talking to him, so you can answer it.
Actually, he's been doing multiple things. He's been doing video. He's been typing answers to the questions. He's been a busy guy.
Yeah.
All right, I'm going to start my share. Let's go with that. Hopefully you can see that.
Yes.
Yeah, let me try moving through slides so you can actually see the slides. Yes.
Yes.
Okay, progress. All right, zoom out of the way. All right, Roger, you want to do a quick introduction or want me to just jump right into it?
No, go ahead. Well, this is Mark Polanski. This is the final presentation this evening on SpaceX Crew 1 and the return of manned spaceflight to the U.S. So please go ahead, Mark.
Okay. And we were live already, so I guess that answers that. Okay, good evening. My name is Mark Polanski. I've been a volunteer and astrophotographer at the McCarthy Observatory for about 10 years. Tonight, I'm going to talk about the Crew 1 mission, which was the first operational launch of astronauts aboard a commercially developed spacecraft, the Crew Dragon. So back in 2005, NASA had some very tough decisions to make. It was just starting to return the space shuttle to flight following the Columbia disaster in 2003. Administrators were worried the shuttle was too costly to fly, and the orbiters were starting to show their age at about 20 years old. The shuttles were also the only option for the United States to get astronauts and cargo to and from the relatively new International Space Station. So NASA did two things. They announced the shuttle was to be retired in 2010 and started the Commercial Orbital Transportation Services, or COTS program. The idea behind COTS was that NASA wanted to focus their resources on actually doing science and operating in space rather than simply getting to space. NASA was looking for the ability to pay a commercial provider to deliver cargo and eventually people to low Earth orbit, in the same way that you or I can pay UPS or FedEx to send a package from one place to another. The COTS program stimulated the commercial space market by providing the money for companies to develop vehicles and provide this capability. Two companies ultimately met the goals of COTS. Orbital ATK, who are now a part of Northrop Grumman, they designed the Cygnus spacecraft, and SpaceX with the Dragon spacecraft. What's a Dragon, besides a fire-breathing mythical creature? In this case, it's a pressurized space capsule designed and built in Hawthorne, California by Space Exploration Technologies, better known as SpaceX. The spacecraft itself has two sections, the main pressurized capsule and the unpressurized trunk. The trunk is exactly what you think it is. It's like the trunk of a car. It has more space, but also more space because it doesn't have doors. It's exposed to the vacuum of space. It's not pressurized. In this photo, the capsule is the top section, and the trunk is the bottom piece with the solar panels. The trunk detaches before reentry and burns up in the atmosphere while the capsule safely splashes down in the ocean. The total delivery capacity is about 13,000 pounds of cargo to the space station, and it can return about 6,600 pounds back to Earth. The return of the cargo is one of Dragon's most important capabilities. When the shuttle did finally retire in 2011, it left the space station without the ability to return any large amounts of cargo, including equipment or science experiments. Dragon launches into low Earth orbit aboard SpaceX's own Falcon 9 liquid-fueled rocket. One of the major goals of SpaceX has been reusability wherever possible, which helps bring down the cost of getting to orbit. At this point, they've practically perfected landing and reusing the Falcon 9 first stage boosters, having successfully landed 64 times, and they've reflown boosters 45 times. The Dragon capsules are also built to be refurbished and reused after splashing down, some flying up to 3 times. While the COTS program was all about developing the commercial vehicles, the follow-up was the Commercial Resupply Services Program, or CRS. CRS was all about the actual cargo deliveries. Think of COTS as providing the money to build a better truck, and CRS as getting paid to make deliveries with that truck. Through CRS, SpaceX and Orbital ATK basically became the UPS and FedEx of space. The first Dragon flew in December of 2010 for the COTS Demo 1 mission. It was just a few laps around the Earth to prove the thing could actually fly and subsequently land. It did both well. It did so well that they were supposed to fly 2 follow-up mission test flights, Demo 2 and Demo 3, but everyone decided they could perform the objectives and combine the 2 into one mission, so they flew Demo 2 Plus in May of 2012. This saw the first successful berthing of a commercial spacecraft to the International Space Station, with a safe return to Earth 3 days later. By October, Dragon received certification to fly operational cargo deliveries regularly, and it has since flown about 20 missions. One quick note here about berthing versus docking. NASA and the ISS partners had concerns about unproven spacecraft approaching the space station. With people on it, it's not hard to see why. Rather than allowing Dragon to fly directly into the station for attachment, it approaches the station and it holds position a few yards away. The station then grabs it with its robotic arm and pulls the spacecraft in for mating under the station's control. This is called berthing. Docking occurs when a spacecraft flies into controlled contact with the station under its own power. You can see in the left picture, the station's robotic arm has a hold on Dragon as it attaches to the station. On the right, this is a Dragon capsule that just returned from its 3rd flight to the space station. You can tell because it has the 2 ISS logos painted on the side of it. This brings us to Dragon version 2. We already know that the retirement of the space shuttle left us without the ability to return cargo from the space station. Dragon 1 helped us take care of that. But the shuttle was also the only human-rated spacecraft operated by the United States. To maintain a NASA presence on the ISS, seats had to be purchased on the Russian Soyuz spacecraft to the tune of $90 million per seat. That's $90 million to fly 1 person to the ISS. Because the human spaceflight implications of retiring the shuttle, the idea behind COTS was extended to include flying humans via the Commercial Crew and Cargo Program Office, or C3PO, because we're all space nerds here, in the introduction of the Commercial Crew Program, CCP. SpaceX answered the call of CCP and unveiled Dragon 2 in May of 2014, a redesigned modern spacecraft, and was awarded a CCP contract along with Boeing, who was developing the Starliner capsule in September of 2014. When SpaceX built Dragon 1, they had no idea how to build a spaceship. Aside from obvious lessons learned from previous capsules like Mercury, Gemini, and Apollo. This time around, they had a lot more experience, having flown Dragon 1 for several years. Dragon 2 was designed with crew in mind from the start, with a capacity for up to 7 astronauts and an emergency launch escape system. To streamline production and reduce costs, a cargo variant of Dragon 2 is also being developed to replace Dragon 1. The cargo payload capacity remains the same as Dragon 1. It's still 13,000 pounds to the station and about 6,600 pounds can return. It also kept the trunk for large unpressurized cargo. With astronaut lives on the line, SpaceX had to work closely with NASA to meet safety and reliability objectives, including upgrades to the Falcon 9 booster. They hired retired astronaut Ken Bowersox to assist with the development and consulted with other astronauts to produce a comfortable, easy-to-fly spacecraft. All in, the estimated cost per seat to the ISS for Crew Dragon ended up being around $55 million, a fair savings from the $90 million of a Soyuz seat and the almost $500 million it cost to fly the space shuttle, which if you have 7 astronauts aboard, works out to about $71 million per seat for the space shuttle. The first Dragon 2, or Crew Dragon, flew on the unmanned Crew Demo 1 mission in March of 2019. The objectives were similar to the Demo 2 cargo mission in 2012. It was a validation of the spacecraft systems to make sure everything worked as designed, and that it was ready to carry humans. It proved the life support, flight control systems, automated docking. Yep, Dragon 2 can dock itself, no more berthing. and safe reentry and splashdown. The mission was successful, which cleared the way for Crew Demo 2. In this picture, you can see the trunk is attached to the capsule. It's a little different from Dragon 1's trunk, with the solar panels built into the trunk's hull, instead of extending out the way they did on Dragon 1. The trunk still detaches before reentry and burns up in the atmosphere while the capsule safely splashes down. After a lot of data review from the Demo 1 mission, and some additional testing, including a spectacular in-flight abort test where SpaceX intentionally blew up a Falcon 9 booster to see how the new launch escape system on the capsule worked, Crew Dragon was ready for prime time, launching test pilot astronauts Bob Behnken and Doug Hurley to the ISS on May 30th of this year. On the first space shuttle mission, STS-1, an American flag was carried on board by the crew. The same flag was flown again on the last space shuttle mission, STS-135. The crew members that flew STS-135 left the flag aboard the ISS, waiting for it to be captured by the next crew that launched from the United States, knowing that the space shuttle was retiring. One of the guys in the picture on the left should look familiar. It's because he is also in the picture on the right. It's Doug Hurley. Doug Hurley flew on the last shuttle mission that placed the flag on the ISS, and he flew on the first Crew Dragon mission and ended up retrieving it. He captured his own flag over 9 years later, saying that it was still in the exact spot he left it on the space station. Crew Demo 2 was a complete success. It returned the United States to domestic human spaceflight and further validated the systems of Crew Dragon, building on the Demo 1 mission. The capsule splashed down safely with Bob and Doug inside on August 2nd, after about 2 months staying on the station. The data review was just completed earlier this week, and Crew Dragon has been officially certified for operational crew missions as of this past Wednesday. Crew 1 was originally scheduled to launch tonight, about 10 minutes ago, but it got bumped to tomorrow because of unfavorable weather conditions at the recovery sites. With a crew launch, there's a lot more to look out for, not just weather at the launch pad, but you have to look downstream for recovery zones or anywhere that the capsule might have to abort. And for SpaceX, the conditions for the recovery of the booster, because they fly that first stage back. The first stage of the Falcon 9 booster being used for Crew 1 is going to be reused for Crew 2. So they have a vested interest in making sure it gets back safely. The Crew Dragon capsule from Demo 2 will also be reused for Crew 2, as SpaceX and NASA build confidence in the performance of the spacecraft and start to realize the cost savings and safety of reusing flight-proven equipment. Falcon 9 and Dragon launched from the historic launch pad 39A at Kennedy Space Center. 39A has been host to some of the greatest human spaceflight accomplishments in history, including the launch of Apollo 8, the first crewed spacecraft to leave low Earth orbit and circle the moon, Apollo 11, the first crewed spacecraft to land on the moon, STS-1, the first space shuttle mission, which was also the first and only flight so far of a new spacecraft that has carried crew on the first launch, and STS-135, the last space shuttle mission ever. They picked it up when SpaceX leased the pad with Demo 2, the first flight of a commercial crew spacecraft, and now Crew 1, the first operational space taxi service. So the Crew 1 mission itself. It consists of Commander Mike Hopkins, pilot Victor Glover, mission specialist Shannon Walker, all from NASA, and mission specialist Soichi Noguchi from the Japan Aerospace Exploration Agency, or JAXA. It's going to launch tomorrow night, hopefully weather permitting, at 7:27 p.m., assuming the weather is good at the launch pad and at the recovery sites. If it were able to launch tonight, the orbital mechanics would have meant it would only take 8 hours to catch up to the space station and rendezvous with it. Tomorrow, because the orbital mechanics are a little bit different, it's going to take 27 hours of flight time to get to the space station. It's okay though, Dragon can support the crew for about 10 days by itself, and once it docks to the space station, it can last 210 days on orbit. Once Dragon safely delivers the crew to the space station, they're going to join Russian colleagues to form the Expedition 64 and 65 crews, staying on the space station for about 6 months. While they're there, they will perform various science experiments and station maintenance tasks. While the Demo 2 mission was the first to fly astronauts since the retirement of the shuttle, it was still a test flight and was not really part of the normal crew rotation of the International Space Station. With the launch of Crew 1 tomorrow evening, hopefully, the modern era of human spaceflight will officially begin, with SpaceX now certified to serve as both space UPS for cargo and space Uber for humans to fly to the ISS. Thank you. Join us next month for a special celebration of the McCarthy Observatory's 20th anniversary. Details will be forthcoming soon. Stay tuned to our Facebook page and our website, and please subscribe to McCarthy Observatory on YouTube.
Roger.
All right, thank you, Mark. That was very interesting. Well, I'm going to turn this back over to Bob Lambert for a moment. He has some late breaking news regarding our Meteor tracking network. So go ahead, Bob.
Yeah, for us, this is very, very exciting news. And we got the input from the partner that we were looking at to partner with the second site for our Meteor tracking. The approval came from the chairman of that organization right after I spoke. So we now have approval to be full partners with the Westport Astronomical Society, which is a long-standing observatory and science center in Westport, in the old Nike Center. And they've done great things for and a controller that goes with it, all the cabling, a computer that was provided to us by the school system in New Milford, and the software that we use, which we purchased. So our system will be there. And the baseline is about, the direct line is about 30 miles, which is a very nice baseline for us. We're very happy with that. So we will be beginning soon, and you'll be seeing things on our website about our progress in deploying the 2-node network. And I expect that we'll have some results quickly. They have some very bright people on their team who can help delve down into the complexity of this thing with more experience than we have. So we're excited. So there's now an official partnership between the McCarthy Observatory and the Westport Astronomical Society. This is a breakthrough for us. Thank you.
And one question on YouTube, Bob, or sorry, on Facebook. The question is, the meteor observed a week ago was a bolide. What did it sound like and how loud was it?
It's a great question. We don't have sound capture on our system at the observatory. And it happened at a time of night where none of us from the observatory saw it. I think Monty Robeson's sister did. And a number of other people, the people at Westport saw it. And I've never heard a report as to the number of decibels. And the American Meteoritic Society doesn't seem to capture that either. So it's a good question. And we'd love to be able to get to the point where we can report on the detonation sound, which is very much a function of how close you are, how much you are underneath the direct flight of the meteor. If you're the further away you are, the less volume it would have, obviously. So it's not only a good question, it's a tricky question, but thanks for it.
Anything else? All right, as Mark mentioned earlier, next month, the second Saturday presentation will be a 20th anniversary celebration of McCarthy Observatory, which was dedicated on December 2nd in 2000. So that is 20 years of science education, student projects, and service to the community. It's a landmark day for us. We hope you can join us. And thank you. That concludes our presentation, and good night.